first part of these day 2 notes is reviewing Sohcahtoa. We've already done review of Sohcahtoa. This was day 0. Hopefully you've already watched those notes and done that homework and have asked me questions if you have them. So just practicing it one more time because you never really practice it too much. The one thing I didn't really talk about a lot of times is the big A versus little a concept. Capital letters are angles. Little letters those are the sides opposite the angles. So for example, when it tells you here to find little c, that means you're finding the hypotenuse. Little c is the side opposite of that angle, which is our 90-degree angle there. So going from angle B down here, I know my opposite. I'm trying to find my hypotenuse, so that is sine. I'm going to leave it as c. Again, just like we were doing with day 0, multiply by c. Divide by the sine of 32. And then we can type that in our calculator, so to the nearest tenth, 28.3. That is our side C there. So continuing on, another example. This time our triangle is not drawn, so we will draw our right triangle. X, Y, and Z does not matter where they go. It's just little z is 10, little x is 22. We're finding the measure of angle y. So we're up there at angle y. So I know my adjacent side and my hypotenuse. So that means I am looking for the cosine. And again, this time we are looking for the angle, so you want to do that second cosine in your calculator. Both of these two problems, your calculator should be in degree mode. You did not get this answer up here for number 1. It's probably because you were still in radians from last time. It should be back in degrees. This one should be in degrees, so second cosine of 10 over 22 to the nearest degree would be 63 degrees. We are going to keep going back and forth between radians and degrees, so you're going to have to get familiar with doing that. So now, going back into the way that we are going to be doing trig here in Algebra 2, is our triangles are going to almost always be linked to the coordinate plane. So we still have the right triangles. All those properties of your right triangles are still going to be exactly the same. It's just this time we're going to be referencing it to that coordinate plane. So here's an example. Here's your y-axis. Here's your x-axis. So this triangle is over here drawn in quadrant 1. So when we take that angle, connect it down, it makes it that right triangle. So there's our 90-degree angle. So all of the right triangle properties are the same. To find any missing side, you would use Pythagorean Theorem. Of course, if you know your Pythagorean triples, that's going to make things go a lot faster. So you can always use those triples and you don't need to show your work for it. But you've got to always remember, you're always going to draw your perpendicular to the x-axis. Never, ever, ever the y. Always to your x-axis. So let's try to play around with this. Let's take a look at example 3 here. So I'm going to draw my coordinate plane. I have the point -12, -9. It exists on a circle. And we're going to talk more about that circle. But that point -12, -9, first thing that pops in my head is I'm in quadrant 3. They want us to find sine, cosine, and tangent of the measure of the angle to the nearest degree. Note, angle is always the measured from the x-axis. So I'm over here in quadrant 3. -12, -9 puts me somewhere down there. So I'm going to connect it to my origin because, again, it always comes from the origin, and I'm going to connect it up to my x-axis. So there is my 90 degree. So if you remember, in order to plot that point, from my origin, I had to go over negative 12. So the length of that side is negative 12. And then I had to go down 9. So the length of this side is 9. So then I have to do my Pythagorean theorem in order to figure out my hypotenuse. Now this is one of our Pythagorean triples. It's a 3, 4, 5, but it is a multiple of my 3, 4, 5. So this is 3 times 3, 4 times 3, so 5 is going to make that side be a 15. And that is going to be positive there. Other way we could have figured out is, of course, using that Pythagorean theorem. And so this would have been 81 plus 144 equals x squared, so 225 equals x squared. Square root it. And we get our 15 for that. So now that we have our three sides, we can figure out our sine, cosine, and tangent. Okay, so picking up sine, cosine, tangent of theta. And again, theta is this little angle. We're using that reference angle between that x-axis and where our triangle actually ended up being. So we got opposite, adjacent, hypotenuse. So our sine would end up being negative 9 over 15. Cosine's negative 12 over 15. And then tangent would be negative 9 over negative 12, which negative over negative would be positive. So then they also want us to find actual theta to the nearest tenth. So either one, any of these, if you type them into your calculator and you hit second sine, second cosine, whichever one, you should end up getting your angle. But what ends up happening is when you type it in your calculator, you end up getting a negative 36.9. But we know that's not right, because negative 36.9 would be over here in quadrant 4. So that means we have a reference angle of 36.9. Because I'm in quadrant 3, I'm going to add 180 to it. We get 216.9 as our angle. And we'll talk more about what I just did in a few days. Okay. Moving on, going on to reciprocal functions. So if you remember, reciprocals means you're flipping. So if we have x, reciprocal is 1 over x. So here we go. We have sine. Sine is opposite over hypotenuse, which is y over x, which you're probably wondering, where does the y come from? So if we have our triangle, let's say we're in the first quadrant, here's our radius from the origin to whatever point we are dealing with. This would be your x value, because remember you start at the origin, your x would go over, your y would go up. So we're over here at theta. So sine is y over the radius. So our cosecant, which is what CSC stands for, is cosecant. That is our reciprocal of sine. So cosecant would be sine flipped over. So a hypotenuse over opposite, or your radius over y, or you'll even see some people refer to it as 1 over sine. It is all the same thing, just matters what you are looking at. So this one is secant. So secant is the reciprocal of cosine, so it would be 1 over cosine. Or hypotenuse over adjacent, or r over x. And then tangent really is the same as sine over cosine. Again, we'll talk about that a little bit more, but it is your opposite over your adjacent, or your y over your x. So cotangent would be adjacent over opposite, x over y, or 1 over tangent. So there's a lot of different ways you can represent it. So let's take a look at an example here of our trig functions and our reciprocal trig functions. So we're going from angle A. If you look at all these are off of angle A. So here's opposite, adjacent, hypotenuse. I don't know my adjacent side yet, so I need to figure that out. I'm going to use my Pythagorean Theorem. I'm going to call it A, because I'm looking for the adjacent side. So A squared is going to be 21, because 5 squared is 25. Subtract my 4 over. That's where I get my 21. I take my square root. And because I am in the second quadrant, I want it to be negative. This distance is supposed to be a negative number because you're going to the left of your origin there. So negative square root of 21. So now to figure out my ratios, sine opposite over hypotenuse, so 2 over 5. Cosecant is the reciprocal of that, so 5 over 2. Cosine is my adjacent side over my hypotenuse, so negative square root of 21 over 5. Secant is that reciprocal, but we get a little bit of a trouble part here because we can't have that square root of 21 in our denominator, so we have to rationalize it like we did back several units ago. So I'm going to multiply the top and bottom by that square root of 21. I get negative 5 radical 21 over 21. So that's what our secant value ends up being. And then tangent opposite over adjacent. Again, I gotta clean up that radical in the denominator by rationalizing it, so I get negative 2 square root of 21 over 21. Cotangent, I'm just gonna take this first one and flip it, because that's gonna be a little easier. Negative square root of 21 over 2. So those are our trig functions again, and then how you find their reciprocals. Let's try some examples that are a little bit different here. So a right triangle, or no, example 2, if, again that just stands for angle, is an angle in the fourth quadrant drawn to the x-axis. Alright, so I'm just going to stop there. I'm going to draw my triangle first. It's in the fourth quadrant. My angle I'm dealing with is right there. And cosine of the angle is 1/3. So cosine is adjacent over hypotenuse. Determine the exact value of cosecant and show how you arrived at your answer. So first thing I need to figure out is I need to figure out that side right there. So I'm going to call that side x. And I'm going to do my Pythagorean theorem. Again, 3 squared is 9, 1 squared is 1, subtract that over, gives me my 8. Square root it. Simplify my square root of 8, not into a decimal, but into the radical form. This would be negative 2 radical 2. Again, I wanted the negative because it's going down. It's in the fourth quadrant. That side should be a negative side. Those properties all still hold true. So then, to get cosecant, I need to start with sine, because cosecant is the reciprocal of sine. So my sine value here would be negative 2 radical 2 over 3. So cosecant is the reciprocal of that. Again, can't leave that radical 2 in the denominator, so we'll multiply the top and bottom by it. I get negative 3 radical 2 over 4. So with those reciprocals, you've got to find the easier trig function first, so your sine, cosine, or tangent first, and then you find the reciprocal of it in order to get those reciprocal functions. So it's a little bit of an extra step to it. So, next one. This time we know the cosecant value is 5 over 4. Then what is theta? So I'm going to draw it. Both my numbers here, 5 and the 4, those are both positive, so that tells me I'm in here in quadrant 1. Again, here is my theta angle that I am dealing with. Okay, so cosecant again is the reciprocal of sine. So my sine value is 4 over 5. So this is 4, this is 5. This is a Pythagorean triple, so my other side is a 3. So they want us to figure out what is theta. So I'm going to use sine because I can't do the angle thing with the cosecant. It doesn't work. We don't have that button in our calculator. We can do it with sine. So I got to do sine to the negative 1 of 4/5. So that means your second sign in your calculator. And to the nearest degree, we get 53 degrees. All right, and our fourth one over here. So we're given the point negative 3, 3. So negative 3, 3, right there. And then that creates our right triangle. Again, here's our theta. We're always dealing with that one in there. This side is negative 3 because you had to go over to negative 3. And then we had to go up to 3. So we go up to 3. They want us to find tangent, secant, and then the measure of the angle itself. So tangent we can find. It's the opposite over the adjacent. So our tangent here is a negative 1. Secant I can't find yet because I need to know the length of my hypotenuse. So again, Pythagorean Theorem. You find my hypotenuse there. Square root, square root. 3 radical 2 is the length of my hypotenuse. So my secant is the reciprocal of cosine. So cosine is adjacent over hypotenuse. So secant is hypotenuse over adjacent. So that would be 3 radical 2 over negative 3. So that would simplify to be a negative radical 2. So again, it's about manipulating the functions we know to get our reciprocals. And then last one, they want us to find the measure of the angle to the nearest degree. So if we try to do tangent to the negative 1 of negative 1, so if you type that in a calculator, again, it gives you a negative 45, but we know it's not negative 45. Negative 45 is over here in the fourth quadrant. So that means we have a reference angle of 45 degrees. So 180 minus 45 means we have a 135 degree angle here. All right. So continuing on with this. So we've been dealing with everything in terms of our 4 quadrants, quadrants 1, 2, 3, 4. We're going to clean that up a little bit more and get more specific. It's not just specifically quadrants 1, 2, 3, 4. It's in reference to what we refer to as the unit circle. The unit circle is used a lot in our trigonometry unit. So if you recall, you had 2 special right triangles that you dealt with last year. The 45, 45, 90, and the 30, 60, 90. So what ended up happening is there were certain rules that you had to apply there, but we can still do Pythagorean Theorem. So for this 45, 45, 90, if I do my Pythagorean, so x squared plus x squared, because it's a 45, 45, these 2 side lengths are going to be the same. So that's why they're both x. X squared plus x squared equals 1 squared. Add these, we get 2x squared. Excuse me. Divide by my 2, and I get x squared equals 1/2. So then I would have to square root it. The square root of 1 is 1. 2 not being a perfect square, I can't actually do that. But again, we have to rationalize. So we end up with the square root of 2 over 2. So this side is the square root of 2 over 2. This side is the square root of 2 over 2. With the 30, 60, 90, what ends up happening is the side opposite your 30 is always half of whatever this is. So that's going to be 1/2 if that hypotenuse there is a 1. And then that ends up being radical 3 over 2, again, when we do our, excuse me, Pythagorean Theorem. So what happens is they took those 2 special right triangles. All right, sorry guys, I had a little bit of coughing fit. So let's pick back up. So again, as I was saying, we are taking our 30, 60, 90 right triangles, and we're going to shove them into this beautiful little diagram here that we call the unit circle. Now, the reason we call it the unit circle is because the length of these radii in here, every single radii is a 1. That's why it's called a unit circle, because all of those radii are 1. So the length of the radii, 1. So we have all of these beautiful angles in here. Let's go through what we have. We got our 0, our 90, our 180. Scooch down a little bit more. Got my 270 down there. If you recall, this would also be 360. Those are our quadrantals. Remember, those are the ones where the terminal sides would end up being on your x or y axes. Those are our quadrantals. So those are important ones. So then each of these creates little triangles within here. Actually, you know what? I think I'm going to do those in different colors so that they stand out. I use my highlight. So here's my 30-degree triangle. I'll go with a very different color. We'll make it Christmassy. My 45. My 60. So those are my special right triangles that we were just talking about up above, but plugged into this unit circle. So this angle here is a 30-degree angle. That's why I got my 30 out there. The second one, that would be a 45-degree angle. Hence the 45 out there. And then the big one is our 60-degree angle in there. Now, if you remember, the 30, 60, 90 were all the same. So this angle here being 60 means that this one here is 30. It's still in there. It's just flip-flopped. So they took this red triangle here and they flip-flopped it to put the 60-degree angle here. So 30, 60, 90 right triangles. So what ends up happening with this unit circle is these points here all have very specific values. So for the 30, this would end up being the point radical 3 over 2 comma 1/2. For the 45, this ends up being radical 2 over 2, radical 2 over 2. And for the 60, this ends up being 1/2 and then radical 3 over 2. And again, it goes with our special right triangles up above. The 45 is the easier one. So that's saying this length here is radical 2 over 2 and this length here is radical 2 over 2, which we already know to be true. For the 60, since your x is 1/2, that means this side is 1/2, which is true because that's opposite of your 30. This side is your radical 3 over 2, which is the one opposite of your 60, which we found up above to be true. And then the same thing with the 30. So the little 30, here's your side opposite. That is our y value. That's 1/2. This would be opposite the 60, so that's why your x is radical 3 over 2. So it's using those right triangles up above and using the lengths of the sides opposite those angles. And it repeats the pattern over in the other quadrants. So this one right here would have a reference angle of 30 degrees. So it's going to follow the same properties as my 30-degree angle over here. The only difference is because I'm to the left of my origin, my x value would be negative. So negative radical 3 over 2 comma 1/2. 45, same thing. My x would be negative because I'm over in my second quadrant where x is always negative. So negative radical 2 over 2, negative 1/2 radical 3 over 2. So it's following the same pattern because it has the same reference angles. Reference angles of 30, 45, and then 60. And then the same thing down here in quadrant 3, 30, 45, and then 60. 30 is always going to be the one closest to your x-axis because it is the smallest angle. Quadrant 3, though, all of your values are negative. X is negative, y is negative. Oh, it should be negative. Negative 1/2, negative radical 3 over 2. And then fourth quadrant, again, same thing, only this time it's your y only that is negative, because you would go a positive x distance over and then down for your y. Now they don't always, let's finish writing this here first. They don't always do quadrant 2, 3, or 4 of our unit circle. Generally we kind of focus on this and then keep in mind what sign values that they should have, whether they're positive or negative. But that is our unit circle. So, what does that help us figure out? So consider our unit circle over here on the right with our angle theta drawn in. There's my theta. Again, it's always the one by the origin next to your x-axis here. So if I were trying to find my sine value, well, first off, this side would be length of x. This side would be the length of y. Because it's a unit circle, my hypotenuse there is a 1. So sine is y over 1, opposite over hypotenuse, which is just simply y. Cosine would be adjacent over 1, which would simply be x. So what that tells us, when we are in the unit circle, whatever the point is, so whatever this coordinate point is, the x portion of that point is your cosine value, the y portion is your sine value. So let's say, I don't know, this looks kind of like it's in 45 land. So if it was a 45-degree angle, my coordinates would be radical 2 over 2, and then radical 2 over 2. So that means I would have a sine value of radical 2 over 2 because that's the y value, and my x would be radical 2 over 2 because that's the x value. Let's practice some more of these. Keep flipping back and forth with your unit circle if you need to. But if you take a look, all of these we're going to be dealing primarily with just the first quadrant for now. So, unquestionably, the most important fact to memorize. Y is your sine value, x is your cosine value. So, keeping that in mind, again, I have this here, so I don't want to keep flipping back and forth. So here's my 30. Here's my 45. Here's my 60. So, they want us to first find sine of 30. So if I go over to my 30, sine value is my y, so my sine is 1/2. Cosine of 30 would be the x portion of it. And then tangent is sine over cosine. So 1/2 over the square root of 3 over 2. So, fraction rules. Keep, change, flip. So I get 1 over the square root of 3. Rationalize, and I get radical 3 over 3. That one had a little bit more work to it. 45. Sine is the y portion. Cosine is the x. Tangent is sine over cosine, which would be radical 2 over 2 over itself. Anything over itself is 1. Next one, sine of 60, again, y portion. Again, here was our 60. Cosine is the x. Tangent would be y over x. which ends up being radical 3 once you clean that up. So if you know a point on the unit circle, x is your cosine, y is your sine, always. So let's take a look at the next one. The terminal ray of an angle drawn in standard position passes through the point negative 0.6, comma 0.8, which lies on the unit circle. That's the key thing right there. So find the value of sine. Again, because it's on the unit circle, sine is just the y value. So sine would be 0.8. And then you're done. Nothing else to do. It is also important, though, to be able to determine the sign, positive or negative, of each of the two basic trig functions for an angle whose terminal ray lies in a given quadrant. So, what ends up happening? Here's my coordinates there. So in the first quadrant, everything is positive. Everything's happy there. Everything's positive. In the second quadrant, if you remember, over here your x value is negative. Because your x value is negative, that makes your cosine negative, because that would involve the adjacent side, and it's going to make your tangent negative, because again, it involves the adjacent side. Sine, however, would still be positive, because sine is your y value. Y would be a positive number there. So then down here in quadrant 3, y would be negative because you'd have to go down. X would be negative because you have to go down. Tangent would end up being positive because sine over cosine, negative over negative, would be positive. So then over here in quadrant 4, sine again is y, so that's going to be negative. Cosine is your x, that would become positive. And tangent, negative over positive, would be negative. So there are a lot of different acronyms that people use to help them remember this. But in quadrant 1, all of them are positive. Quadrant 2, it's just the sine value. Quadrant 3, it's your tan that's positive. And quadrant 4, it's your cosine that is positive. So if you go in order, quadrants 1, 2, 3, 4, there's a lot of them that people use again. All students take calculus. They use that to remember all S, T, and C. I had a teacher in high school who, when she taught this to me, it always stuck out in my head. All schools torture children. So that's the one I always use, because even still to this day, that's how I remember, all schools torture children. Because with all students take calculus, not every student takes calculus, so that's not even a true statement. All right, so let's take a look at our last page here. We're going to practice putting this all together. So a summary of our trig values. And again, I'm going to highlight those 4, because those are the quadrantal values. So for the quadrantal values, I'll use white because I'm going to write over here in the blue. Again, here is my unit circle. So 0 and 360 would hit over here, which will be the point 1, 0, just like it would be on a normal graphing. You would go over 1 because it's a unit circle. It's always a distance of 1 and up nothing. So here at 90, that would be the point 0, 1. You don't go left, right, anything. You go up. This would be the point negative 1, 0. And this would be 0, negative 1. So to fill this in again, sine is y, cosine is x, tangent is y over x. So for my 0 and my 360, the sine value would be 0, cosine would be 1, tangent would be 0 over 1, which ends up being 0. For sine, or for 90, sine would be 1, cosine would be 0, tangent would be 1 over 0, which is not possible, so it would be undefined. That has no value. For 180, that'd be 0, negative 1. 0 over negative 1 would be a 0. 270 would be negative 1, 0. -1. And again, I'm just getting these values from looking at the xy portions of my unit circle. Being the quadrantals, they involve 0 and 1 or -1. So that's how those ones work. 30, 45, and 60. You gotta memorize these. This is how we're gonna be able to get fast with these. We got 1/2, radical 3 over 2, and then radical 3 over 3. Radical 2 over 2, radical 2 over 2, 1. Radical 3 over 2, 1/2, and radical 3. These are the most important ones. You gotta have those ones memorized. Because 30, 45, 60, those are going to be our reference angles that we're using a lot. So, putting this all together, the whole reason we did all this was to be able to figure out values of various angles throughout our coordinate plane. So, let's take a look at this first part. Let's first figure out what quadrants we're in. So, 315, that's going to be in quadrant 4. Now again, I got to bring back my all schools torture children. We need that because in quadrant 4, our sign has a negative value because we got a C here in quadrant 4. So that means only cosine is positive there. So sine is negative in quadrant 4. Our reference angle for 315 would be 45 degrees. So that means I got to find negative sine of 45, which if I look at my chart up above is radical 2 over 2. So I'm looking at negative radical 2 over 2. That is the sine value for 315. So let's try this again. 210. That is in quadrant 3. Tangent in quadrant 3 is positive because we have our little there, so that's telling us it's positive. Our reference angle for 210, because we're in quadrant 3, would be 210 minus 180, so that gives me a 30. So I want tangent of 30. So that's radical 3 over 3. That is the tangent value of 210. And these are what we call our exact values. We talked about those a little bit during logs. They're coming back again. All right. Let's have you try these next two. Pause the video. Try. All right, number 4, I might have given you a little bit of a tricky time there because it was cosecant. So I had to find the sine of 30 because 30 is my reference angle, and then I had to flip it. So the sine of 30 was 1/2. 1/2 flipped is where my 2 ended up coming from. 270. That one is a quadrantal. So you don't have to pay attention to any of those other parts. There's no reference angle for a quadrantal. So cosine of 270 is 0. That's up in my chart. All right, go ahead and try these other 3 again. I'm going to star 6 and 8 because you got to find the reciprocal and then flip it. All right, so hopefully that's what you got for those last 3. Let me know if you need help.